Chapter 5, Radical Operations. This begins on page 149. We're going to start doing some questions on page 151. Question 1, true or false? A, the equations x squared equals 9 and x equals 3 are equivalent. Well, let's look at those two questions. Okay, so x squared equals 9. Well, if I take the root of both sides, I'm going to have the square root of x is x, the square root of 9. Well, one possibility is 3 because I know 3 times 3 does equal 9. But negative 3 times negative 3 also equals positive 9. So there are two answers. We have x equals 3 and x equals negative 3. Quite often we write those together as x equals plus or minus 3. And if you look at that, those are not equal. So the answer for A is false. B, the equation x squared equals negative 9 has no real solutions. Again, let's take the square root of both sides. Square root of x squared is x. The square root of negative 9 is an imaginary number. It is not real. For B, the answer is true. C, the equation x squared equals 0 has no solution. Let's take the root of both sides. Root of x squared is x. The root of 0 is 0. 0 times 0 is 0. So that works. And so that means there is a solution. So if I look at C, the equation x equals 0 has no solution. That is false because there is one. D, the equation x cubed equals 27 has the solution x equals plus or minus 3. We're doing a cubed, so we have to take the cubed root. So we need 3 numbers that will multiply by themselves, the same number, to make 27, and that would be 3. So this is going to be x equals 3. See, I know plus 3 is correct. Let's try minus 3, so negative 3. Well, we'll do the positive one as well. I know 3 times 3 times 3 equals 27. Negative 3 times negative 3 is positive 9 times a negative 3 is negative 27, so this isn't right. So D would be false. E, the equation root x equals negative 4 has no real solution. I guess we're going to have to square both sides. If I square both sides, I get x equals 16. Now the problem with this is that it's not negative. How do I go back? So if I go and take my root, I'm trying to go backwards to double check this, and I get the square root of x. The square root of 16 is plus or minus 4. Now because the answer that I get when I'm trying to go back and check my answer is different than the question itself, then I would have to say there isn't a real solution, so C would be true. Question 2, solve for x. Please note that solve has an equal sign. So I'm solving, there is an equal sign in there. E, x to the 4th equals 16. Well, I'm going to take the 4th root of both sides. 4th root of x to the 4th is the same as x. 4th root of 16, 2 times 2 times 2 times 2 is 16. So this is going to be a 2. But it could be a minus 2 as well because we have 4 of them. So if I have 2 times, if I have them negative 2s, so 4 negative 2s, that also equals a positive 16. So this could be plus or minus 2. Please note there is another way we can do this. We can use fractions. So we're taking the 4th root. That is the same as multiplying both sides by an exponent of 1/4. So I'm just going to go here. So remember the 4th root is the same as a fractional exponent. So I could rewrite this as a fractional exponent. And our exponent rules, remember we multiply these two together. So 4 divided by 4 equals 1. And remember that 16 is 2 to the 4th. So that you can also do this with exponents if you want. Question 4, simplify. Please note there is no equals sign. So we're not going to find an answer per se for x and y. We're just simplifying it, making it simpler. G, root of x squared y squared. Well, if I take the square root, do it separately, so the square root of x squared is x. The square root of y squared is y, but there's a problem. This cannot be negative, because as soon as it's negative, we can't take the square root of it. So we need to do something to make sure that this answer is positive, and I'm going to put these two straight lines beside it. That is called absolute value. So these two lines here are the absolute value lines, and those make sure that the number inside them is positive. Absolute value is very similar to, well, you can think of it in terms of distance. So say, for example, you walk 5 meters forward, or you walk 5 meters backwards, you still walked 5 meters. So it's like distance without respect to direction. That is what absolute value is. If you want to look at a little written explanation on that, that is on the bottom of page 149. Let's look at m. The square root of 16x to the 6th y to the 8th. Okay, so the square root of 16 is 4. So we know 4 times 4 is 16. The square root of x to the 6th, remember we need two groups, so it'll be x cubed. And square root of y to the 8th is y to the 4th. Now if I'm double checking, we want all of these positive. The only one we have a problem with is this cubed root here, because if that becomes like -2, we have 3 of them together, it's now going to be a negative answer. And we want to keep it positive, so we're going to put our absolute value sign around that x cubed. 5a, simplify. Assume all variables represent positive numbers. Excellent. So for this one, we don't have to worry about absolute values as much because we're making that assumption and it's stated at the beginning. The cubed root of 27. Well, that's going to be 3 times 3 times 3. So the cubed root of 27 is 3. Again, you can do this with exponents. So 3 cubed to the 1/3. Remember that the 1/3 represents your cubed root. So 1/3 times 3 equals 1. So you get 3 to the 1, which equals 3. 6. Simplify. Assume that the variables represent real numbers. G, 4th root of 2 minus x to the 4th. 2 minus x to the 4th. We have 4 of these guys. Okay. And we're taking the 4th root of that, so we need a group of 4, so the whole thing just comes out as 2 minus x. We could look at that as exponents as well. So 2 minus x to the 4th, and our 4th root becomes a 1/4 exponent. Multiply your exponents together, you get a 1, because 4 divided by 4 equals 1. So you get 2 minus x all to the 1. So we know the variables are real numbers, which means they could also be a negative number. Or they could be a number, well actually even if x is a positive number that is greater than 2, then it will make the number under the root negative, and that won't exist. So we need to make sure that the answer is going to be positive. So we need to put our absolute value signs around it. 6i, the square root of x squared plus 4x plus 4. How are we going to find groups of 2 for this? We're doing the square root, we need a group of 2. Let's factor. Two numbers that multiply to 4 and add to 4. That's a positive 2 and a positive 2. So this is the same thing as writing the square root of x plus 2 squared. We have a group of 2. So the answer here would be x plus 2. If I wanted to do it with exponents, it would be written like this. 2 times 1/2 equals 1. But any number goes. So that means x plus 2 could be a negative value. If x is negative 10 plus 2, that would make a negative 8. So we need our absolute value sign. So add our absolute value signs to make sure our number underneath the root is going to be positive, and we're good. Question 7, rewrite as a single radical. These are a little scary looking. I'm going to remind you of your exponent rules. So I'm going to do it as exponents first. So x to the 1/4 times x to the 1/3. And your exponent rules tell you that you'll multiply those together. So 1/4 times 1/3, that's 1/12. So this is x to the 1/12, which would be the 12th root of x. We can also multiply the radicands together. So 3 times 4 equals 12. 12th root of x. 7c, the third root of the 4th root of the square root of x. Remember there's a 2 here. It's a square root. So again, you can multiply all of the radicands together. So 3 times 4 is 12, times 2 is 24. 24th root of x. You can do it as exponents. So x to the 1/2, 1/4, and then our outside root is 1/3. We're going to multiply our exponents together, x to the 1/24, so the 24th root of x. You should at least practice doing the exponent method. It's going to come up a little bit later, especially when we have things changing, but that comes later. So just a little bit of practice now would be good.